Hey everyone, glad to get the opportunity to present our project here, and my name is Zehui. I will present the first part of our projects, and next part will be presented by my group partner, Feng Shaohan. Firstly, for the given paper, we read the details and fully understand the main idea in the paper, and moreover, we refer to some other related papers for more improvements and make further progress on our own research. Now let's begin. For the title of this paper, Metaheuristics algorithm for the deployment for 5G, we decompose it for two parts: the 5G deployments and Metaheuristic algorithms. Now I will show the outline for this presentation. First, I will introduce the background, and then for the problems and solutions and simulation results, I will give some details. Later is the most focus point in this presentation, the further improvements. So now I will give some background. What's 5G? Briefly speaking, it means the fifth generation mobile communication system. The first G, start of personal communication. The second G, allow users to transmit data like text messaging, allow user to send some voice signals which could be converted into digital signals. And the third G is the world of smartphones, which has a multimedia communication functions here. Through fourth G, the LTE service, it delivers data 8 times faster than the third G. Finally comes our fifth G. It comes to our lives, which could send data gigabyte per second, which will be 200 times faster than now existing third G or fourth G mobile networks. So I will make an example here. Use on 4G, like you want to download one 10G movie in 4G here. You will use 20 seconds or so. But use on 5G, here you could use maximum speed of 50 Gbps, which means with one movie, use less than 1 second. Now you may have a direct impression. So, with the come of 5th generation mobile network, there will be also many problems. The first obvious one is how to efficiently let the user to enjoy this service. How to deploy the 5G system base station to support this service. Just like the topic of this paper. Now I'll give a general deployment figure to show you guys. Now some device will connect to here the macro cell, like the cell towers, and some machine-to-machine or device-to-device communication will be coexist in the same network. So the IoT, Internet of Things, or the Internet of Vehicle, this kind of things could be reality. It allows the appearance of some smart homes, smart cars, etc. And for this paper, the author formulated the problem into one hyperdense deployment problems. And then for this kind of problems, Metaheuristics algorithms is present for this kind of problems. Now for this kind of problems, the 5G cell deployments, the heterogeneity is really a big characteristic. Since for various communications, some small cells, macro cells, picocells, femtocells, some relay nodes, and some Wi-Fi nodes will be coexist in the same network. So, and meanwhile, for deployment problem in a 5G environment, a number of issues need to take into account, including this kind of things as I showed here. And actually, in this paper, the author considered 3 main objectives in the same time to formulate these problems, as shown here: more coverage, less interference, and less cost. And I will show some notation here. These 3 variables, as I discussed before, is the cost, interference, and coverage. And I have shown some red rectangular here to show some important denotations. Here it means the set of users. Here is the set of candidate points. We should deploy our cells into these points. And for the C1 means the set of existing power cells. It means before deployment, some real macro cell for 3G or 4G systems are already there to describe some real environments. And to To solve these problems, there are many kinds of cells, like show the yellow bracket and the green bracket. Of course, different cells have different deploy cost and different communication range. And here is really important for this kind of problems, genetic algorithms. It's a fitness value. I will discuss it later. So the problem is here. Minimize this kind of cost, interference, and meanwhile maximize the coverage. Also, it's subject to we have to deploy the cells into some kind of candidate points. And this three expression means the three expression for these three variables. First is the cost for our deployment cost, of course. And here is the expression for SNR. And the third is the coverage. Here means the coverage for the user. Here means the coverage for the area. And later I show the Metaheuristics solution, the basic structure, like that. The basic idea of Metaheuristics is to use the transition, evaluation, and determination. These three operator is really important for this kind of problems. And in the algorithm, here S means the current solution, V means the candidate solution, and F is to evaluate the value of S here. So when the termination criteria is not met, the whole loop will continue. And just like that, the paper present one genetic algorithms. Here, the key part of this paper is kind of this slide. A simple example uses genetic algorithms. The evaluation operator means to evaluate the solution, and the selection operator determines the search directions, and the crossover and mutation operator transits current solution from one state to another. And for another kind of really important issue is how to represent the population. Here is a set of solutions. Each solution or chromosome here in S is encoded as a sequence of sub-solutions genes. Here Si could be S1I, S2I, etc. Each sub-solution assumes a value of the coordinate, and also it assumes a value in the range of 1 to 5. I will give an example to show more details. Here, when these two expressions are guaranteed, it means for this kind of position, a fetal cell will deploy into this coordinate, and it's here. So actually, it's not easy. It's not difficult to understand. So intuitively, the GA method considers the trade-off of these kind of problems, which combine more than one objective compared with pure greedy one. Now I see one comparison figure to obvious showing these two different results. I see two points here, 19.6 and 19.5. Actually, for these 2 points are really close to each other, but in the left it uses a macro cell, whereas in the right, for the genetic one, it uses a fetal cell, which also could provide the coverage with less interference in the same time. And for the more detailed numbers here, the author also gave one table to show the great performance in terms of these three objective results. Although the coverage is better, but the interference is very bad. For GA, the coverage is not the best, but for the cost and inference are relatively more promising. It outperforms other two algorithms. And for the future direction and improvements here, we just denote these three. Actually, this paper is really easy to understand. So here we figure out several improvements. And for future directions improvements, will be presented by my partner Shaohan.
Thank you, Zehui. My partner has introduced the background of 5G and the model in this paper. As he said, there are some drawbacks in this paper. In this piece of slide, I list some references that give us some ideas which could be used in the modification. We both saw that there existed some pre-motion according to the algorithms, objective, and the model of this paper. Firstly, let's take a look at its algorithm. This paper compares only two algorithms, greedy algorithm and genetic algorithm. However, as we all know that there exists much more heuristic algorithms than just two. Comparing the result of only two algorithms is not wise. But it will cost a lot of time in computation if we want to compare other results produced by different algorithms. A paper named a hyper-heuristic scheduling algorithm for cloud, which is the first reference in the list, provides an architecture for different heuristic algorithms to embed it into and construct a new heuristic algorithm. With the help of low-level heuristic selection algorithm. As shown in the left picture of this slide, one of the heuristic algorithms in the pool of candidate heuristics H1, H2, and Hn will be selected by the low-level heuristic selection algorithm as heuristic algorithm to be performed, which is referred to as HI in this picture. For this kind of heuristics, low-level heuristic selection and acceptance are the two essential operators to determine which heuristic algorithm is to be selected and whether the selected heuristic algorithm will be continuously used or not. LLH selection will combine information concerning the recent effectiveness of the heuristic, the recent effectiveness of consecutive pairs of heuristics, and the amount of time since the heuristic was lasted together into consideration. Different from the LLH selection operator that plays the role of determining the heuristic algorithm, the acceptance operator plays the role of determining the time to select a new heuristic algorithm, such as when the HI gets stuck with a solution for a certain number of iterations, or when the HI falls into local optimum. As for the candidate heuristics, there are a lot of paper provides their algorithms inside which could be used, like parental ranking in reference 5 and non-dominated sorting genetic algorithm in reference 7. Now I want to combine the objective and the background together to discuss, because how the model is built will determine what the objective function looks like. The original objective function wants to minimize the cost and the interference and the maximal coverage rate. So the objective function which could be introduced briefly is alpha times cost plus beta times interference plus gamma times 1 over coverage rate, where the sum of alpha, beta, and gamma is 1. The objective function uses weight parameters alpha, beta, and gamma to unify different units, so that different units could be put into one objective function. However, it is not reasonable. And for the real world, we have already used 4G for a while. When it comes to the 5G, 4G will not be shut down immediately, so there will be a period that 4G and 5G coexist, which means some users would continue using 4G and some others would choose 5G because of different expenses. And the deployment of 5G is not an overnight establishment, but a long-term process. So what modification we want to do are to unify units in the objective function and take 4G into consideration. The income of several operators is affected by the user's density and market response. And after considering these two factors, the serial operators will make a choice to hold 4G or deploy 5G and shut down 4G in a unit area. Then minimize cost and interference in original function will turn to minimize the cost of equipment and control interference, which is divided into two parts: cost of 4G and the cost of 5G. The cost of 4G only contains the cost of operating 4G, and the cost of 5G contains the cost of deploying and operating 5G. As for the coverage rate, I think it is already not necessary to be considered about, because the whole area is already covered by 4G and first, and where the serial operators need to consider about is the area to deploy 5G, which will factor the user's expenses. And last, the objective will change into minimize the cost of equipment and controlling interference and maximal income. So the objective function is user's choice of 4G or 5G times their price respectively minus cost of operating 4G and minus the cost of deploying and operating 5G. Then the units in this objective function are unified. So till now, the introduction of our modification has completed. Thank you for your watching.